Are we live?
Uh, yeah, I think we are live.
Awesome. Hey everyone. Let's get started with today's live stream. Um, I'm Ashar, and today we have Bilal with us. And we are today going to talk about agent architectures, specifically parallelization and agent orchestration with AI agents in Langbase. So yeah, before we get into that, I'm just gonna take a minute to introduce ourselves. I am Ashur. I am a founding engineer here at Langbase, and I am basically a backend engineer, and I deal with all of the backend stuff. So yeah, Bilal, can you go ahead and introduce yourself?
Yeah, so hello everyone. I'm Bilal, uh, founding engineer at Langbase, and I overlook the full stack and AI related stuff here at Langbase. And yeah, excited for the live stream today.
Awesome, awesome. So yeah, like AI agents have grew a lot, and in the past a couple of years, and yeah, so we have had a lot of clients who've come to us like with this thick complexity about how asking about like how they should be able to build complex AI agents that are easily scalable and if, can perform well in production environments. And so what we have done is like we go back to like basics of like how agent architectures, like how agents should be implemented. And for that purpose, we what we have done is like we have taken all of the common AI agent architectures that are basically that you will be basically facing or building in the production environments, and we have documented them, all of them, in our docs. And what those architectures layout is basically for you is that the basically what they do is like they tell you like these are the basic architectures that you will be building in your everyday AI when you are building everyday AI agents. So without any further ado, let's dive into those architectures and what they are, and let's discuss them. So I'm gonna go ahead and share my screen. So are you able to see my screen? I'm loud. Is it good?
Yep.
Awesome. So here, before getting into agent architectures, like what is actually an agent, right? That is the most commonly asked question. Like, what is an AI actual agent? An AI agent is basically an autonomous system that basically processes input, takes your input, processes it, makes decisions, and then on the basis of that, it takes action. And why? Basically, that's what an AI agent is. And basically, to build those AI agents, you need all of these agent architectures. So we here at Langbase, what we have done is like we have these reference agent architectures where we have like augmented LLM, prompt chaining, agentic routing, agent parallelization, orchestration workers, evaluator and optimizer, augmented LLM with tools, and memory agents. So all of these reference architectures are being used by our clients in production, where they have implemented different AI agents using these architectures. Today we are here to discuss the most common pattern of the AI agents, which is the agent parallelization, which is basically how you are able to run multiple agent tasks in parallel, and orchestration. So how basically this is about dealing with how an AI agent autonomously decides like how it is going to perform a task, and then it is going to write those subtasks down and perform those tasks, and then summarize the results for you, and then you will have your output. So let's dive into what is agent parallelization. yeah, so here in agent parallelization, as you can see in the reference architecture diagram here, you have one input, which is basically this one, you give your AI agent any input, and on the basis of that, your architecture decides like it has to do like one, two, three, or however many calls in parallel that it is able to do. And then once all of these calls are done and the results are in, you pass that information into an aggregator agent there, which basically what it does is like it compiles all of the output from the calls, the parallel calls before, and give you a processed output. So this is basically basically a parallel architecture. And with parallel architecture, what you are able to achieve is basically you're able to build like run multiple LLM calls, because you know that each LLM call could take a lot of time, right? So running them in parallel, which basically you will have to basically you have to evaluate yourself, like if for example an LLM call does not require an input from let's suppose another LLM step, right? So you can run all of those calls in parallel in your agent, and then basically pass all of the compiled the output into one aggregator, and then basically get your results from that. Here it's basically says the same thing. Parallelization runs multiple LLM tasks at the same time to improve speed or accuracy. It works by splitting a task into independent parts and are generating multiple responses for comparison. And that's where you basically take the complete advantage of parallelization.
Uh, I think
Mhm.
in my experience, what I've seen is a lot of people are uh, uh, sacrificing latency uh, while just because they do not parallelize their architecture. So if your agent and some step of your agent is not in the critical path, it is best to parallelize it and not wait for it for improving UX and latency and overall improving the layer response times. So I think that's
Yeah.
another area where parallelization helps a lot.
Yeah, exactly. Like if an agent is basically an LLM call is not in your critical path, like, and if you can run them in parallel, that's where you can get a lot of wins in terms of latency, because AI agents can surely take a lot of time to get you results, and this a parallelization technique method is going to speed things up for you as well. And obviously it's going to be a win-win in in your AI agent architecture. Yeah, so let's see. So yeah, we have basically what's happening here in this example. So we have a coded example over here for parallelization, where we basically discuss like how this is going to happen, how the parallelization is going to be implemented. So for that, let me share like my let me share my other screen with you guys, and we can go over the example of agent parallelization. So what I've done here is basically um, prepared a basic uh, project template where I've just installed Langbase SDK for TypeScript and .env package for reading my environment variables. So I've defined my environment variables in this file. Obviously, for the purposes of this live stream, I'm not going to show those variables, but yeah. So let's dive into the parallel.ts file. So this is where the agent parallelization is happening. So what we have done is basically we have first of all we have initiated the Langbase SDK, and for here we are just calling we have an email which is basically acting as our input, and we have a main function. So in this function, what is happening is that we have taken an example of taking a user's email as an input and doing a sentiment analysis on it, and then basically preparing a summary of that input, and then on the basis of those things, those two steps, we will decide that there's going to be an aggregator which is going to be act as a decision maker agent. And what it will do is like it will tell us like, should we respond to this email or should we not, right? So the as you can see over here, like in this example, like both of these steps, the sentiment analysis and summarize email, both of these steps can happen, actually happen in parallel. Like there is no dependency of these steps, onto each other, so we can both run both of them in parallel. And after that, once we are done, we can collect that information and pass it to the email decision maker and ask it to basically tell us like what's the decision based on the email summary and email sentiment, like what should we do. So let's see what's happening here. So basically what we are doing is like we are defining like this is the email sentiment agent function, and in here we are doing a Langbase agent dot run call where what is basically we have defined our model as the GPT-5 mini latest version, and we have given in instructions like you are a helpful assistant that can analyze the sentiment of the email, only respond with the sentiment either positive, negative, or neutral, and do not include any markdown formatting, code blocks, uh, yada yada yada. The response should be raw JSON object, and here we have given it the example response like sentiment, positive or negative or neutral, whatever it is based on the input. We have given it the API key for the LLM, and we are setting the stream to false because we don't need to use stream right now. Uh, and we are giving the user email that we have gotten as input to the input of this agent, and then we are just basically on when we get the output from this agent, what we are doing is like we are parsing it and taking the sentiment out like this because we are expecting the response to be in this format. And so this is basically the email sentiment agent. Then with the next thing we are defining is the summarize email agent, where what we have we're doing is like we obviously again we are setting the model, setting the instruction like you're a helpful assistant that can summarize the emails, only respond with summary, do not include anything, and then there is the example response like summary and then the summary of the email that we are expecting. And then we are passing our usual inputs, API keys, and stream false, and basically the user input as an user email as an input. And from here, we are taking out the summary and returning it in to the and returning it as a function response. So, and the third thing that the aggregator there here is basically the decision maker that's going to take the sentiment and both the summary, and it's going to decide like whether we should respond to this email or not, whether a response is needed or not. So basically, we are basically defining another agent call where we have given the model, we are giving it the instruction like this is the decision maker. You're the decision maker that analyzes and decides if the email requires a response or not, and use the following key values accordingly, like respond, either it's going to be a true false category, it's even categorizing like is it a spam or not a spam, and priority, like should you respond to this user's email on priority or not. And the expected values are low, medium, high, and urgent. So an email could be um, uh, uh, can take a low priority, if it is something that's not that response is not needed in some cases, like for example a customer support on customer support, a frustrated agent emails you, a frustrated customer emails you about your product, like something is not working right and they need help right away. So obviously that's going to be taken, that's going to take a high or urgent response priority. Yeah, then these general instructions about this formatting and how the email should look like, and then we have the input as email summary as the summary, and the sentiment here as we are passing the sentiment here. and then we are basically returning the whole response. So here what happens, like how do we parallelize the request? So basically what we can do is like we wrap the both of these calls, the sentiment agent call and the summary agent call, into a promise.all to make them basically run in parallel. So so both of these tasks are basically both of these tasks are running in parallel and not blocking each other. And here basically we get a win in terms of latency, that both of these things will be in parallel. And once we get both of these, both summary and sentiment, we are going to call the email decision maker, where from where we will get the decision about the email, that should we respond to it, what is the category and what is the priority of the email, and at the end we are just returning the email. So yeah, so let's go ahead. Let's run this response. Run this agent and in our terminal. So we have parallel. So what is happening right now is it's sending basically two requests at the same time, which is basically the sentiment and summary. So we had the email where we had the email, this email as an input. So for example, hi John, I am really frustrated with the service that I received yesterday. So this looks like a typical customer support email where a user is frustrated. The product was faulty and customer repair support was unhelpful. How can I apply for a refund? Thanks. So the again, this looks like a typical customer support email to you, where basically the customer is frustrated about the service of the service of the product, and they want a refund. So so this is email is acting as our input right now. So as you can see over here, the summary sentiment of this email is obviously negative, and here's the summary, which where this says the customer is disappointed with the service, the product was faulty, customer support was helpful, and they are asking how to apply for a refund. And should respond is basically true, like yeah, you should definitely respond to it, and the category for it is not spam, obviously, and the priority is high. So basically the response priority of this thing is high. So yeah, we can, I think, run another email. So for example, let's suppose I can just tell it like spam, and we say congratulations, you have won a Walmart gift card. Click here for to claim your prize. Like this looks like a typical spam email to me
Yeah.
and to LLM as well. All right, so
Hopefully.
let's yeah. Sorry.
Yeah, I said hopefully. It
Yeah,
should
yeah,
detect
yeah. Hopefully.
spam thing. Yeah.
Yeah, exactly. So this is, for example, this is a typical example of a spam email, right? So which basically they are congratulating you for winning $1,000 Walmart gift card. Obviously, it doesn't happen in real life, and click here for to claim your prize. This could be another phishing attack or something. But yeah, this is the email that we have passed to our agent, which is basically running all of the parallel agent and basically telling you like it's going to have a sentiment, like obviously the sentiment is positive because this is something that's they are claiming that you have won the lottery or something. And here is a summary where the email claims that the recipient won $1,000 Walmart gift card and urges them to click a link to claim the prize, likely a phishing or a scam attempt. So you respond? Obviously not. It's false. Category is spam and priority is very low. So yeah, that's how basically you are able to take advantage of agent parallelization in your production environments, is by basically wrapping their function calls, the agent calls into a promise.all function, and then basically running them in parallel in your production, so that you can get output from your agents more quickly. So I know I've spoken a lot until now. Bilal, any questions from your end?
Yeah, I think this is a good example where it makes sense to have three different agents doing their sets of tasks independently rather than having a single agent doing everything
Yeah,
together. Because if
yeah,
I
yeah, yeah.
think if it was to be, if you were to be one single agent, the spam one being positive sentiment would potentially have resulted in a false positive, right? So yeah, this is another just another good example of where you should diversify your task into separate agents and
Yeah.
create a workflow on top of it.
Yeah, exactly. Like this is not just one agent call. This is like three agent calls happening in all in one agent, and this is where you can also say like this is a multi-agent, right? Multi-agent workflow right here, where you're defining like three different agent calls, running two of them in parallel, so that you would get a response and then aggregating them all together into through one another agent to get the final result, right? So yeah,
Yeah, and
that's
and we have
important to highlight.
purposely kept this example this simple because we want to show how simple it is to build a core AI workflow. You can attach any sort of integration on top of it. We support agent, MCP agents, so you could potentially have these route to your Slack workspace and have a sort of a sales query system where you can easily get on top of all your queries and basically filter them out. And this is something we use natively as well. We dogfood this particular architecture of agents, and yeah, there's a bunch of stuff you can do by building on top of this architecture.
Yeah, exactly. Like this is mainly basically just an example, just to show you like the power of utilizing agents in production and how far you can take them on Langbase. So yeah, let's now again go, or let me share my other screen with you, and let's go over the other architecture example that we have, which is basically an orchestration worker. So here, this is a little bit more complex than just an agent parallelization, because that in parallelization you are just basically giving your input into multiple agents at the same time and telling them to just go and run, and then you know um, create taking their whole of that output into one aggregator and then producing one good output. But you do that when basically when the thing the agents that you need to run, that you know about them, like the steps that you need to take are defined. So for example, let's suppose in a real life example, let's suppose you are faced with something like you in a situation where you have to you don't know what the next step is going to be, or maybe you haven't decided yet. But there as well you can take full advantage of agent AI agents by basically implementing agentic orchestration. So what agentic orchestration is basically is where you take input from the user, right, and you pass it to an orchestrator agent, where basically that orchestrator agent is going to decide like how many tasks that it needs to run in order to get the required result from your prompt, like whatever you want to do. For example, right now what we are going to discuss is writing a blog post, right? But writing that blog post requires a lot of research, a couple of tasks bind together. But what we are going to do is like we are just going to give it an input, like write a blog post for me. So we are only interested in the output of that agent. We
So
what
it will be like a
Mhm.
super agent that will run
Exactly.
agents on its own, deciding what it
Yeah, yeah,
needs
yeah.
based on input.
Yeah,
and based on the
it's
situation.
going to
Yeah,
take
makes
it's
sense.
going to take the whole input, and it's going to decide like what steps that it needs to take to get to the required output, right? And then it's going to run those steps dynamically all together, and then pass it through a synthesizer to create a final output for us. So that's what this is like. You do is like you give it an input, you pass it to an agent call that is basically an agent that is acting as an orchestrator, and then it's going to decide like how many LLM calls it needs to make to get to the required output. So for example, let's say it's the decider for like 8 or 10 calls. So what it will do is like all run all of those calls in parallel for you, and then once all of those calls are done, all of those agents are done, it will basically pass it to or pass all of those output to a synthesizer, which basically a synthesizer agent will basically take all of that, take all of the output from the previous calls and take it as an input and produce the desired output for the user agent. Any questions so far, Bilal? I know it's a tough one,
That sounds very interesting. I would love to see it in code
right?
and
Yeah.
through an example,
So
probably.
yeah. So here basically here like if you go to our docs, and like this is where we have explained like what is happening. We have defined an example for you, and we have basically explained like what is happening inside of it. Like if you are trying to find it, like it's just over here. So here is the code for it, and here if you click on it, this explanation will appear. Where basically it tells you like an orchestrator agent where we are going to go through a planning phase, takes a complex task as an input. It will analyze the task and break it down into smaller, manageable subtasks. Because an AI agent, as long like if you ask an AI agent to do a bunch of different things for you in just one LLM call, it will obviously it is going to right now it's going to mess it up. So what you need to do is like what's your strategy should be here is that you should break it down into smaller manageable pieces of subtasks that an AI agent can perform really well, right? So if I give my AI agent like one AI agent, and take that agent email example, the customer email example as right now, like if I give that email to just one agent, I bet you like it will not be able to do like I have to I have to produce a summary for it. I have to detect its sentiment, then basically they take a decision like what we need to do. We need to respond, do we not need to respond, what's the category, so if I give all of that instructions to just one agent, I'm 100% I'm pretty certain that it's
Makes
going to
sense.
mess it up. It's going to mess it up,
Yeah,
right? And maybe it will hallucinate at some point, right? Because it's like it's going like the task is like going in separate directions where it needs to do separate
yeah,
different things. But if I put
which
like
is
sorry.
it makes perfect sense. Yeah, and by
Yeah,
the way, this reminds me of all the coding agents that we see today. By the way, they are all based basically on this architecture. Stuff you see like Cursor, Codex, Cloud Code, they all have a planning phase,
yeah, for
and
sure.
then they basically spawn out smaller agents to afford that delegate
Yeah,
tasks further.
exactly, exactly.
Oh,
So basically what we are doing here is like we are trying like in this particular example, in the orchestration example, we are taking the input, we are analyzing it, and we are deciding like how much smaller manageable pieces we can divide our tasks in. And then what we're doing is we're returning that both analysis and the list of subtasks, right? And then comes in the worker agents, the execution phase, basically, where we are going to run all of those tasks in parallel using promise.all. And each worker is going to get an original task for context, right? And their specific subtask to completion. So the original task is going to basically give the worker an idea, give the LLM an idea about what we are trying to achieve. And their specific subtasks, like the agent's specific subtasks, will tell us like this is your responsibility, go get it done. So over here, and once all of that is done, what we can do is like we are going to use the synthesizer agent, that is the integration phase, where we are basically take all of the outputs from the workers, all of the worker outputs, and combine them into a cohesive final result, right? So and basically it will also ensure that the output is flows naturally. So yeah, in this example, basically we show like how to use to create a blog post about remote work, where it might break down the tasks into sections about productivity, work-life balance, environmental impact, and process each section in parallel, combine them into a cohesive blog post. And what makes this interesting is that architectural approach to task management, like using AI to both plan and execute while maintaining context throughout the process. Like we are maintaining the context and we are executing the tasks, planning and executing the tasks at the same time. So yeah, so basically here is the orchestration worker example that I'm going to discuss uh, by sharing my other screen. Hold on. While I'm sharing my other screen, Bilal, do you have any other questions, like, or any comments?
Yeah, I would love to see it in code. And uh, yeah, I suppose the same thing can be done with tool calls with
Mm-hmm.
in the same sort of architecture. But yeah, I think let's go over
Yeah,
these
that's
examples first.
that's that's going to become a little bit complex for this live stream, I think.
Yeah,
Yeah.
but I think that's
Mhm.
fundamentally the same process, right?
That's fundamentally the same process, exactly. Yeah. So let's start. Let's go over this orchestration worker example. So yeah, for here we have just like imported the Langbase SDK, initiated the .env config so that our process env are defined. We have basically initiated our Langbase SDK, when this is the main orchestration workflow where we are basically calling the whole agent. And here we have a main function just for the sake of calling this orchestration agent in an async manner. So what is the tasks that we are going to do? Like we are going to tell it like write a blog post about the benefits of remote work, include sections on productivity, work-life balance, environment, and environmental impact. So here we are basically telling this agent to write a blog post about benefits of remote work, and we are asking it to include different sections about productivity, and other related sections of this particular topic. And here from here we call this agent and let's dive into this agent. So here it has taken a task and it has basically divided itself into the step number one is going to be the orchestrator LLM, where it's going to break down the task. So here we have basically made an agent call to Langbase, where we have defined the model for the I've just used GPT-5 mini, but obviously you can use any of the LLM models out there, whatever you find, you can find, you have according to your useful according to your use case. So for example, and next I've defined the instructions for this orchestrator agent, where I'm telling it like you're an orchestrator agent, analyze users tasks and break it into smaller distinct subtasks, return your response in JSON format with an analysis of the task extracted from the task, and no extra steps like proofreading, summarizing, etc. A list of subtasks, each with a description, what needs to be done. So do not include any markdown formatting. This is just formatting instructions, I think. And then the response should be a raw JSON object so that we can, take it as an input and take it and pass it as an input to another to our worker agent. And here is going to be our example response, where basically it's going to have an analysis of the task that we are going to perform. The task is to describe the benefits and drawbacks of electric cars, for example. and the subtasks. Like this is going to be the list of subtasks that are going to be performed. So for example, task number one is going to be, write about the benefits of the electric car. Task number two can be write about the drawbacks of the electric car. So here basically it has divided defined two subtasks. But yeah, this is just an example response. So let's and now we have passed in the API key that's required to run the agent, and the input, and which is going to be the task that we have passed to our agent. So yeah, so here we basically we are going to get the orchestration results of the by running this call. And we what we are going to do is next is basically is we are going to parse the final output and get the analysis and subtasks, and we are going to log them obviously for obvious reasons, so that we are able to see like what is the analysis of the, and what are the subtasks that are going to be performed in parallel, so that we will see the results. And then the step two is going to be like process all of the subtasks that are defined here, and basically run them. We're basically what we are doing. We are doing it in a promise.all, so that uh, all of those tasks are happening in parallel, and this will save us so much time basically. And here we have basically given it like the model for the task and the instructions. Like you are a worker agent working on a specific part of a larger task. You are given a subtask, you need to complete it, and you are given the original task and the subtasks, and you need to complete the subtask. Like we are basically explicitly telling the agent that you need to complete the subtasks. And here we have given it the API key. Stream is false for obvious reasons right now, and the input is basically the original task is what our task is. Your specific subtask is basically subtask dot description, like where basically this is the description that we are talking about here, and provide a concise report for the subtasks. Only respond with response of the subtask, basically.
So, is this the synthesizer agent, or is it working the subtasks first?
So basically this is going to work the subtasks. So basically in the first
All right,
step we had defined the subtask, right? So this is going to
makes
run
sense.
all of those subtasks, right, for you, in a parallel fashion, and it is going to return you the result in the form of a object, where it's going to tell you like this is a subtask, and this is the result of that subtask for you, right? And then once we have the worker agent results, what we are going to do is like we are going to prepare an input for the synthesizer agent. So we are going to basically jot down all of the subtask description and their results into one big input, and then we are going to pass all of that input to hold on, let me yeah. So we are going to pass all of that input into the synthesizer agent. That's basically what you're where I've designed the instructions like you are an expert synthesizer agent, combine the following results into a cohesive final output, and then we are going to basically give it the input in the form of content, where basically it's saying that combine the following results into a complete one solution. uh, any questions, any confusions right now, till now, Bilal?
I think let's see it in action,
Yeah,
and then
yeah,
I
yeah,
have a couple of questions.
sure, sure. Yeah, I'm excited to run this. So basically, and then after running the whole agent, I'm basically what we are doing is like we are outputting, logging it for our observability. But yeah, and then at the end, we just return the output for the agent, where you can use this in your in your production AI agents. But yeah, let's go ahead and run this thing. Let's write a blog post about the benefits of remote work. I think we all take benefits from it. So yeah, that I'm going to run this thing. and we are right now, it's basically what behind the scenes what it is doing is like it's taking my input, the input that I've given it, the task that I've given it, and it's breaking it down into, uh, a subtasks, a list of subtasks, and summary. And basically, once that is generated, which basically it will basically start running all of those subtasks in parallel. So here we have like that, this is
There
the
we go.
task analysis where, yeah, there we go. So this is the task analysis, like write a blog post describing the benefits of remote work, ensuring it includes distinct sections on productivity, work life balance, environmental impact, and produces a coherent, well structured article suitable for publishing. So I didn't tell that, like I didn't tell the agent to, I didn't tell it in my input. Like the agent is smart enough to understand that this is what I need to do at the end, like I have to produce a coherent, well structured article suitable for publishing, right? So here are the generated subtasks. The first one is like define the target audience they desire to own, approximate word count for the blog post. The other one is like this research credible sources, statistics on remote work productivity gains. Create next step, create a compelling title, short meta description that summarizes the post and aids SEO. Next, another task is write an engaging introduction that frames the topic. Then we have write the productivity section, explain how remote work can increase productivity, cite evidence, studies, stuff like that. Next is write the work-life balance section. So basically, the section should describe, how remote work affects work-life balance, include both benefits and potential pitfalls, and share anecdotes or data, give practical suggestions for maintaining boundaries. So these are quite a lot of steps that it has defined. So, oh, we have our final output as well, but let's go over the other tasks that it has generated. So write the environmental impact section. Basically, it should section should contain how remote work reduces commuting emissions. Obviously, it has remote work has an impact on environmental emissions as well, because you're using way less transport here. And yeah, so and office resource use obviously, and provide statistics or simple calculation to illustrate impact and suggest ways companies employees can amplify environmental benefits. Next is write a concise conclusion that summarizes key benefits, reinforces main takeaways, includes a call to action. And then we have add transitioning, side posting between sections, smooth clarity, and proofread and edit, stuff like that for a complete output. So here's the final synthesized output for us. Remote work benefits, productivity, work-life balance, and sustainability. Meta description. So here's our meta description. Discover how remote work boosts productivity, improves work-life balance, reduces environmental impact. Environmental impact backed by research and practical tips. Approximate word counts is 1,000 words. That's good introduction. So here's the introduction. Remote work, but yeah, here's the introduction. Here's the part
Yeah, I
about
think you can
productivity.
just go
Hmm.
over the sections, and yeah, I think the overall quality is much better because it
Yeah,
was
yeah,
done
yeah.
this way, sort of sequential section-wise manner,
Yeah.
and yeah, looks good.
Looks good to me, exactly. Yeah. So basically, what it has done is like it has produced an introduction. There's a productivity. You have concrete examples. Here's how to sustain the productivity remotely, and work-life balance. It's talking about the benefits, the pitfalls, the practical boundary strategies, environmental impact, simple calculation to illustrate like the impact of the environments, uh, office energy, and how to implement environmental benefits. And after that, conclusion, next steps. You have like it has selected sources as
Cool.
well, like right? And some of the SEO notes, secondary keywords, suggested slug, and that's about it.
All right.
So I think this is a pretty
So
good example of. Sorry, Bilal, go
yeah,
ahead.
and All right, can we like go back to the code?
Yeah, yeah.
All right, so someone is asking, they want it, uh, what if they want the orchestration worker to create sub agents? How would that
So
work?
this, okay. So this exactly is a sub-agent, right? This is an agent call where basically once the we have decided like with our main orchestrator like LLM call, like how many LLM calls are required. We have basically prepared a list of subtasks, right? And once we go through those subtasks in an orderly manner, we are making an agent call, right? So this exactly is an agent call to perform
So
the whole subtask.
these are all separate sub agents, and this is
Exactly.
not being done by a single agent,
Exactly.
do it all. Yeah,
Exactly.
okay,
Exactly.
cool.
So basically, you can see over here, like I'm basically mapping all of the subtasks one by one in promise.all, and basically I'm running this whole thing in a parallel fashion so that we get, because the amount of tasks that it has produced, like it's quite a lot. Like I think it's around 10 steps, right? So if those 10 steps had, ran in, serial manner, Bilal, you can imagine like how long it would have taken to complete this whole thing, right? So, but the output was clearly, that didn't take a lot of time. I think less than, maybe 2-3 minutes. So yeah.
Yeah,
Uh,
and that brings me to my next question, which is, what if we wanted
mm-hmm,
an agentic orchestration loop like we
mm-hmm,
see in coding agents like Cursor,
mm-hmm,
where,
mm-hmm,
let's say, the user may not want all the tasks to be done right away. So
mm-hmm,
sequential tasks, let's say,
mm-hmm,
uh, they want there are three tasks needed, and they want the first two to be done first. So in
mm-hmm.
that case, I think, uh, can we scroll up to the system prompt of the,
Yeah, yeah, yeah. I
yeah,
think we
this
can do
this
something
one.
here,
So
right?
exactly. So right now we are basically asking it to output the subtasks in a JSON format. You can do the same
Yeah,
in structured outputs. It's basically the same thing. But if you were to build an agentic orchestration loop out of it, I think it would require a tool call. So very simple. Just replace this example response to a tool, and it will intelligently decide, okay, what tasks are required in this particular context right now, and you can then pick those tool calls and execute them on your system. And in the next turn of the conversation, if the user wants the third task to be done now, it can, again, you will get a tool call for the third task. So that's how basically this agentic orchestration loop works, and it works the same way, like this. Just we just replace it with tool calls and uh, create a loop around it. And again, that's why these architectures are so powerful. Once these are like 7, 8 architectures that you need to uh, just go through once and try it out in code, and then you can tackle like hundreds and thousands of use cases of AI agents.
exactly. Yeah, definitely. Like tool calls are way like I think my majorly misunderstood. And once you get the hang of them in a good fashion, like you are able to do a bunch of different things. Like I would say, even go ahead and say that you'll create a super agent for yourself, which is basically doing a bunch of different stuff for you, doing
Exactly.
all sort of
Yeah.
research, getting doing API calls, getting data, because data in the fundamental form is basically very important for an AI agent, and because on the basis of that data, an AI agent is able to get things done, right? So yeah,
Also, I
that's
would
where
love
I think
for
the
you
agent.
to, yeah, I would love for you to quickly touch base on deploying and scaling these agents, and why uh, our serverless AI agent primitives help in this sort of scenario.
Yeah, so basically, right now, what is happening is that this a Langbase agent.run call is basically an LLM call that we allow you to do through our LLM platform, right? But if you are, willing to, if you want to, there is one other way to create an agent, that is basically through pipes on our system, which basically what you could do is like, just go to our platform, or you have the API, you have the SDK, you can create your pipes, settle them down, like define your tasks in those pipes, and call them. Basically every pipe on our platform has its own API call. Basically, you get your own API for each of those pipes, and you can call those pipes using our SDK, and using anything else. So basically, using the REST API, you can also use the REST API as well. We have that as well in any language right now, and we recently launched Python SDK as well. So you can also use our SDK in Python to call dual call AI agents on our platform. Basically, those agents will be deployed on our platform with an API that you will be calling through either a REST API or one of our SDKs, like either Python or TypeScript. And that's how basically you will be able to use our platform further, and basically use our platform to build AI agents. And yeah, so basically once you're done building your code, you can just push your code to whatever platform that you are deploying on, and it is going to work from there. uh, I think that's about it. I don't think, I think, did I miss anything, Lal?
Uh, yeah, no, makes perfect sense. Uh, you get a one-click deployment and you get a ready serverless API which you can start sending requests to right away.
Yeah, exactly. So
All right, so I
I
think
think that's a sorry.
we had a couple of questions that we've answered along the way, and there
Mm-hmm.
is one question around why we chose TypeScript and uh, what does the future of deploying AI agents look like in the future 3 years?
Okay.
Whether it will be in TypeScript, uh, and whether they should move to C Sharp or not. So my
Okay.
2 cents before I hand it over to you, my 2 cents
Mm-hmm.
would be just look at the market. Like the most popular languages for AI agents right now are Python and then TypeScript, and I don't see any reason unless you have a complicated um computation of some sort to use C Sharp for these. Um, but yeah, TypeScript and is more than able to do all of this stuff, and it is ultimately uh, very developer focused in terms of experience. But yeah,
So
I think the future looks bright. I think it's all TypeScript and Python.
yeah, yeah, for sure. So I think what I would add here is that, first of all, our CEO is a huge fan of web, and that's why we have basically built it in TypeScript first, and that's why we launched the Python SDK after it. But the thing is that you have to think about applications, right? So right now, web is the most popular way of developing applications, right? So by building the SDK and this thing, agents in TypeScript, and showing our users like how they can do it in TypeScript, we are basically enabling them to use these agents in productions in their applications, and this is like just an API call away for them, right? So that's what we are displaying over here. Exactly. Right. So basically, if I don't know, like before AI agents came along, I was not even aware that Python was being used in production environment. Obviously, Python was being used in production environments, but as a developer, I have basically spent my whole career in web, and I'm more passionate about doing things in web, right? So that I'm not dismissing Python in any manner, but I think there is a very bright future for TypeScript as well, because of the range of applications out there, and the ease of integration that we have built, the layer that they have built for introducing AI directly into your application, without changing, needing to rewrite the whole code base, or doing something else that's basically uh, people could call crazy. But yeah.
Yeah, and if you happen to have a code base, your code base in any language, it's just ultimately as easy as integrating an API call. So
Yeah,
we have an
exactly.
API. It doesn't matter what language you are on. You can just start using it.
Exactly. Any other questions, lad?
I think that is it, and we are also on time.
Yeah,
So
yeah, yeah. So yeah, it
awesome.
was fun, I think. Yeah, and yeah, we will be continuing these live streams for the rest of the year. And yeah, let's just use your code for good, and see you next time.
See you.
Ciao.